Here's where you can find out more about me at any point if you would like to ask a question. It might help if you also consider the possibility of following along at menti.com. Use the code that's there available, and then if you ask questions, if I don't get the chance to answer them today, I promise that I will answer them in an article sometime soon. Okay, let me switch to the correct window. I have too many open. So what is it about refactoring that makes me want to talk about this today? And it boils down to this. Refactoring is one of those things that some programmers kind of think, oh, I should be doing this. I shouldn't give in to the impulse of wanting to change things by throwing some big part of it away and writing it again from scratch. When the book Refactoring was first published in 1999, the subtitle of the book, maybe people forget, is Improving the Design of Existing Code. The whole point of refactoring is for us to be able to improve the design of code without resorting to throwing a big part of it away and writing it from scratch. And you can think of a variety of reasons for that. I'm not going to try to read the entire first third of that book to you now. But if you are a programmer, if you work with programmers and you've discussed this problem before, then you might have encountered this dilemma, I guess, where refactoring seems like something that you should do and something that you should be good at, something that you should improve at, but you just never seem to really get past the very basics. You never feel quite comfortable refactoring enough to really dive into it and to make it a centerpiece of how you design software. One of the promises of test-driven development is the ability to defer commitment to design choices until the last responsible moment. That way you keep your options open, and it becomes the cost of changing the design and adapting it to what you learn about what the system needs to do. You're reducing that cost as much as you can over time. You're essentially not committing until you absolutely have to. And so I've worked with hundreds of programmers over the last 20 years, many of whom never seem to break through the feeling of being a beginner in refactoring. They never seem to quite get there. And one of the ways that this seems to happen, one of the good news, if there's any silver lining in the current global travel and work disruption, it's that some of you who are accustomed to working in an environment where you're being watched very closely, or you feel like you're being watched very closely, where experiments are likely to lead to very public failures, which certainly I like to avoid public failure as much as the next person, or maybe where a culture of control makes you feel like you don't have the autonomy to decide how to approach improving the designs of your systems. Suddenly, you maybe find yourself outside of the prying eyes of the people around you. You find yourself suddenly with more autonomy, with less supervision, and therefore there's a lower cost of failure in trying to make small changes into the way you work. And this might give you an opportunity then to adopt refactoring as more of a centerpiece to the way you design software. And so I am encouraging you to take this opportunity to practice deliberately. Practice deliberately. It's possible that you've never had a better opportunity in your entire career to make space in your work to practice something deliberately, to go beyond just trying to do things under the pressure of working on tasks, under time pressure, under schedule pressure, under the pressure of people being able to see the details of how you work. That you can focus on the technique instead of the results, that you can give yourself space to struggle, that you don't have to get it right the first time, and that you can invest in increasing your capacity to do better work, not just because you want the vague satisfaction of doing the better work, although that's nice and that's important, but that you can also give that better work to others, that you're making this investment not just in yourself for your own satisfaction or to feel better about what you're doing, but to do that in order to be able to give freely of that better work to the people around you, to your employers, to your manager, to the other people in your group. And maybe the most, well, I shouldn't say the most, but one common cause of this rut, and it's something that I've seen in at least dozens of programmers over the years, is they get trapped in this loop where they feel like, I don't see how to refactor this code. I see how to rewrite it. I have an idea of what I think it should look like, but I don't see how to get there through a steady stream of reversible design changes. I mean, that's really part of the point of refactoring. Refactoring is not just changing stuff. Refactoring isn't even just improving the design of existing code. Refactoring really is figuring out how to go from here to there in a series of relatively small reversible design changes. And the idea of these small reversible design changes is that if a third of the way in this direction, you start to see that maybe that direction will be slightly better, then you haven't made a big commitment to go from here to there. You can change course as you go along. You can take advantage of the fact that you learn things. As Ron Jeffries always liked to say, when I learn something, I want it to be good news about today, not bad news about yesterday. One of the most difficult things about working in knowledge work is that feeling that we've learned something and we can't use what we've learned. And so refactoring really, this idea of this small, or the sequence of small reversible steps allows us to use that. So if you don't see how to get from here to there in those small steps, then really it seems like your only choice is to either give up or to try and stumble and go slowly, and it feels painful and there are false starts and you have to go back and try again and take a few steps in this direction and say, no, that was wrong, let me go this way instead. And if you don't feel confident in your ability to do that, then that's where a lot of this rut comes from. You essentially convince yourself that you're never going to be able to refactor because you never let yourself try. And it gets worse than that, that not only do you not trust yourself to refactor, but when you don't trust yourself to refactor, that means that every design decision that you made or that other people made before you entered the room, that you feel stuck with it because no one is ever going to give you permission, schedule, budget to rebuild part of the code that took a week, 2 weeks, a month to build. Now, I say nobody ever, and obviously those are wrong. That's just sloppy speaking. What I really mean is most of the refactoring projects that are blessed by the typical enterprise are really rewrite the whole system at a large scale because we can no longer justify pumping more money into this horrible code base, which feels much different and is much riskier than finding some small part of the code that you wrote 6 weeks ago or that somebody else wrote a year ago and realizing, if we just change this, and this, then adding that new feature would be really easy. And if you don't feel confident in your ability, if you don't trust your ability to refactor code, then you will always, you will run the risk of feeling stuck with decisions rather than feeling that you have the confidence and the freedom to change them. And in the extreme case, and I'm not exaggerating, I've seen this a number of times, and I certainly experienced it during my time at IBM, you might reach the point where you just start to look around and think, I'm never going to be able to do good work here. I never get to make big enough decisions. I never get to have a real impact. Once a decision is made, I'm never going to be able to change it. I'll never have the opportunity to do good work here. And that's devastating. There's no reason for you to feel like that if you know how to practice deliberately and can take advantage of the opportunity you have now to do it. And so here's how it works. And I'm not just talking about, you might have the image in your mind of like the equivalent of how, the great sports teams and athletes practice, where they do a lot of drills and they spend most of their time doing that. And that's great for a football team, for a baseball team, for table tennis players. You have the image of them, bashing a ball against the wall for 3 hours at a time. And you're probably thinking, nobody is going to pay me to do that. And you're right. But what you're missing is the reason why the bit of practice that you are able to do isn't working. And that's what psychologists call chunking. Now, I'm not a psychologist. I don't even play one on TV. So forgive me if you have a deeper understanding of this concept than I do. This is as much as I understand. And if I say anything wrong, then please, please correct me later off stage when you won't embarrass me in front of everyone who's watching. But the basic idea of chunking is, think of it like the way you learn how to read. If you are reading the words on the screen right now, think back to, and you probably can't think back to a time when you had to concentrate carefully on every single symbol on the screen. And you had to recognize that this symbol over here represents the letter A, and this symbol over here represents the letter E, and this symbol over here represents the letter G. That requires a lot of conscious effort. But through repetition, eventually you chunk. And chunking is that point where instead of seeing pieces, you start to see groups of pieces. Each of those is a chunk. And you start to see things like words. And when you start to see words, eventually through practice, you reach the point where instead of seeing the letters, you just see the words directly. And that's chunking. What chunking allows you to do is essentially to, as you practice the steps, and I'm starting to notice here that somehow I think some slides are being skipped, and I'm not sure how that's happening. As you practice the nano steps, the tiny, tiny, tiny steps in your work, you start to chunk. The repetition causes you to chunk, and then you can start to think of what you're doing, not at the level of keystrokes or the level of individual steps, not at the level of individual letters, but you can start to think of the words, the movements, the things that you're typing, the functions, the classes as things. That's chunking. And what that allows you to do is to do those things with much less effort. In fact, what happens is that you repeatedly practice the smaller steps, and you hand off your thinking from system one, or sorry, from system two to system one. System two is involved in trying to figure out how to do each little step of the refactoring, or each little step of reading, of understanding words. And as you practice, eventually you pass that on to system one, and then you end up doing that with much less effort. You do it more fluidly, more easily, with less effort, and more quickly. You also tend to do it more accurately. And in refactoring, let me just check where we're going here. Oh, okay, yeah. So with repetition comes ease, and with ease comes chunking. What happens is that as you repeat things often enough, then the steps become autonomic. You suddenly notice that you're able to do those things without even thinking. So that could be what keystroke is it that I have to use to extract something to a variable? Or which keystroke is it that how do I move this bit of code from here to there? What was that? Oh, right. In Elm, what we can do is we can take some reusable code and first put it in a let block, and then eventually move that let block into a top-level function. Each of those things becomes a step that at some point requires a lot of conscious thought, but through repetition, then at some point you chunk, and those things become effortless. And as they become effortless, this frees your mind to start thinking at a higher level of abstraction. And you just keep doing this forever. As you chunk, you're handing tasks off to system one. And that way, system one has so much more bandwidth to be able to do this stuff, so much more capacity. It becomes much easier. You do it more accurately, more easily, and then you can use your limited system two resources to do more difficult things. So here are some examples of chunking and refactoring. I've chosen these categories. They don't mean anything except that I chose them. So I think of nano steps. That's things like, what are the keystrokes in my editor to move things around? What are the IDE keystrokes for extracting something or inlining something or moving things around? The nano steps also include what I think of as the elementary refactorings that you'll find in Martin Fowler's book. Extracting things, inlining things, renaming things, and moving things. And I put there moving free agents. Some languages call those static functions, where moving them from one module to another doesn't require anything more than really just copying and pasting code. And many programmers get stuck with the nano steps, and they don't take time to practice them. But when they do, eventually they move on to the micro steps, things like introducing delegates, moving, taking. I noticed that there's a little module inside the big module. So I'm going to extract the little group of code into its own little module and use the old module to delegate to the new one. Or I'm going to push details up the call stack respecting the dependency inversion principle. Micro steps can often be like 1 or 2 or 3 nano steps together. And as you practice the nano steps, you start to think of the micro steps as a single thing. And then gradually you get to what I call moves, thanks to my good buddy G-Paw Hill for the suggestion, that moves are more like, they start to feel more like actual design changes. The problem with nanosteps and microsteps is that you have to do a lot of them in a row in order for some outside observer to see that the design is actually changing. Moves are the level at which the design starts to change in a way that everyone can recognize. Collapsing layers, splitting something into 2 layers, replacing inheritance with delegation, replacing side effects with an event listener architecture. As you practice at each level, you stop thinking consciously. System 2 gets out of the way, and you perform those steps with system 1. And then you essentially go from one level to another. And eventually you get to the point where you can think directly in terms of strategies and how to, what is a good way to move this code around. One of my friends, Pat Welsh, talked about really good designers, when they do refactoring and they have chunked for a long time and they've practiced for a long time, the code flexes. It's as though they're working the clay. That was the metaphor that Ward Cunningham used in the beginning for describing evolutionary design. And so these are sort of levels I've identified of chunking and refactoring. And you need to practice a lower level enough to allow chunking to happen so that then system 2 can hand that off to system 1. So what is it like to practice a move? Since I am running a bit short on time, rather than describing this to you, I'll simply put this here as a move that you might try to practice. And there's an article that I've written with the same title of this talk, Breaking Through Your Refactoring Rut, that describes in detail how to actually practice this at the level of what does a practice drill look like. And I've done this with clients where we sat in a room with a handful of programmers for 2 hours, and we spent about an hour doing drills like these. And after doing these drills 2 or 3 or 4 iterations, they've noticed already that they were starting to go faster, that they were starting to feel less effort, and that it was easier for them. And this is, I think, what holds a lot of programmers back, is because they never feel like they have the opportunity to do this. And because it feels weird to practice this kind of stuff, they never do it and they stay stuck in their rut. Chunking leads to confidence, leads to courage. If you don't practice and allow this chunking to happen, then you'll never feel like you are good enough to refactor. You'll feel resistance when you think you ought to refactor. In situations where refactoring you think would be helpful, you won't feel confident enough to do it, and you simply won't. And the alternative of that is that if you allow that chunking to happen, you will feel confidence, you will feel courage, and you will feel hope. You'll be willing to refactor even in a situation where success doesn't feel certain. And that's when you know that it's really working. So start practicing today. Take advantage of this worldwide experiment in working more on your own than perhaps you've ever done in your entire career. And I know that's not true for everyone, but for some of you it's true. And if you're not sure how to start, then start by spending 30 minutes at the end of every task. If you have a task to do that should take you, let's say, 2 or 3 days, I don't think your manager or your project lead or your project manager is going to notice if it takes you 30 minutes longer than you thought it would. There's more than enough slack in there. It'll be fine. Or practice 30 minutes once a week. Pick a drill, try something that you're not good at, and practice it. Take the IDE keyboard shortcut cheat sheet and paste it on the wall, and spend 30 minutes trying to refactor code. And every time you try to use the mouse, stop yourself and learn the keystroke. IntelliJ IDEA has a plugin that essentially reminds you what the keystrokes are for any menu choice that you make, and there's a mode where it will even stop you from using the menu and will say use the keyboard instead. If you try to do real work under pressure this way, you run the risk of becoming too frustrated and giving up. But if you allow yourself to practice deliberately, then you might actually do it. And the good news about this is that it doesn't matter where you practice. It doesn't matter what code you practice on, because at the end of your 30 minutes, you're going to throw your changes away anyway. The odds are almost zero that in that 30 minutes of deliberate practice on nanosteps or microsteps, you'll actually refactor the code in a way that you want to keep it. Probably what you'll end up doing is making the code worse, or taking 2 tiny steps in a 14-step refactoring, and you say, well, I can't keep this. That's fine. Git reset hard. Let it go. Start anywhere, choose any nanostep or microstep, and just start practicing. Throw your work away when you're done. And as long as you keep trying, you're doing it correctly. That's all that matters. Just keep going. Now, you have Slack. You might not realize that you have excess capacity, but you do. And so if nobody complains that you're spending 30 minutes at the end of every task or 30 minutes once a week, if you sort of do that for a few weeks and nobody seems to mind, and you don't, the manager's not inviting you to a one-on-one to discuss why your productivity has gone down, well, then double it. Try an hour. And if after a few weeks or a month, nobody seems to complain if you spend an hour practicing, try 2 hours. You'd be surprised. You have Slack, just use it. What happens relatively soon, sooner than you think, is that the time that you save by practicing what you learn and how you apply it in your regular work, that actually starts to return your investment, your upfront investment in time, sooner than you think. And if people aren't watching you as closely as used to, and if you can still keep, keep your responsibilities to the organization while you're doing this, then use the time and practice. You don't have to do this in your spare time. 30 minutes at the end of every task, 30 minutes once a week is enough to get started. You'd be surprised how much excess capacity you have. So whatever it is that still requires your conscious attention, whatever it is related to refactoring and writing code that where you feel like you have to concentrate in order to do it correctly, start there and practice. Like I said, read my article to get an idea of what a drill looks like, and then adapt that to any other thing that you want to learn, and give that chunking a chance to happen. Repetition leads to chunking, leads to confidence, leads to courage, leads to hope. And wouldn't we all want to work with more hope? So here are a few places that you might start, some articles that you can read. I also do training in evolutionary design and TDD. There's both online training and some kind of hybrid real-time remote training that we can talk about. So if you need help in this direction, I hope this gives you enough to get started. I hope this gives you some feeling like you can do it, because you can. This is what I did. I was no good at this stuff 20 years ago, and I just decided one day that I'd had enough and I want to be better at it because it's going to help, and I practiced. And trust me, if you just start and stick with it, chunking will do all the magic. Hand that work off from System 2 to System 1 and you'll feel much better. So thanks very much for your time and attention. I really appreciate having the chance to talk to you like this. Thank you for allowing me to take up all the available time. And if you'd like to ask questions and you didn't get the chance to ask them here, you can always visit ask.jbrains.ca, and I'd be happy to answer. And I'll make the same offer that I make to everyone. If you ask me a question and you're willing to wait indefinitely for the answer, then that service is free. And if you need a better service level agreement, if for whatever reason you need answers sooner than that, then we can talk about how much that costs. Thanks very much for your time and attention.
Thank you, JB. That was great. That was I think that I wouldn't say fundamental, is that the word? Basic? No. Really important building blocks. I don't know how to phrase this.
I think those words all work. I like fundamental, but in the good sense. I call myself a fundamentalist, but in the good way.
A fundamentalist. Okay, that's you should definitely need to clarify when you say that.
That's why I add, but in the good way.
Yeah, right. Okay, thank you very much for that. So essentially, it sounds a little bit like you're asking us to cheat our employers.
So I get this question a fair bit, and I would say no. I believe that a job is a medium of exchange of energy and time for money, and nothing else. And anything else that you do is volunteer work. Now, I like volunteer work. I do volunteer work. We all do volunteer work. But I think it's really important to be conscious of when you are doing volunteer work, and to remember that the nature of volunteer work is that you do it on your own terms. When other people coerce you into doing volunteer work, it's not volunteer work anymore. That's now terms of employment.
Yep.
And so when I say that you have excess capacity and you just have to try to use it, I'm not asking you to cheat your employer. If anything, what I'm asking you to do is to recognize the inefficiencies in the way you work for your company and to put that spare capacity to good use. I mean, we probably all heard the whole, if you actually map your value stream, and if you're more than 7 to 10% efficient, then you're in the 95th percentile of companies around the world. That means that you have an awful lot of spare capacity. Instead of using it, allowing yourself to stay stuck in doing the same old things the same old way, with the same old mistakes and the same old wasted effort and time and energy, use that spare capacity a better way. And it might not be socially acceptable for you to do this in the open. That's the reality that we live in when we work with other people.
There's always Facebook,
Well, exactly. So, I mean, we've all heard about the studies that say, the reason that a 6-hour work day makes more sense is that when you spend 10 hours at work, you do 6 hours of work in 10 hours because you check email, you get up and go for coffee, you chat with your coworkers, and all that stuff is important. I'm just saying, let's not pretend that we don't have this spare capacity. We do have it. Let's find a way to use some of it more for good. And if it's not socially acceptable for you to practice deliberately out in the open at work, that's fine. Then take it upon yourself to start small. That's why I say 30 minutes. I meant that literally. If you're afraid of what people are going to think, start by using such a small amount of time that almost certainly nobody will notice. And if nobody indeed notices, then work your way up from there. Don't suddenly decide you're going to spend 6 hours a day practicing and tell your project manager, live with it. That's not what I'm suggesting.
I agree with that. So it actually reminds me of the funny story my friend told me once, that he ran a company, and he said, I really like employing young mothers, because they go away on parental leave, and when they come back, they don't want to work full time, but they give you like 150%. So
one of the things that I wrote down during Linda's talk was the idea that clearly we shouldn't be trying to work on single tasks for 6 hours a day.
No.
That's just too much.
That's
having two tasks to bounce back and forth to let system one work on for a while. That's absolutely a great idea.
Yeah.
And everything that we can get system one to do for us is going to make us squeeze more value out of the energy that we spend on work. And this is just one way to
the whole notion of spending more hours to get more things done is completely flawed. If only I stare a little more intently on the screen, and the things will fix themselves. No, they won't. All right. So but the whole concept is, of course, to approach this piece by piece, right? If you feel that your coding skills are not that great yet, maybe you want to get better. Baby steps is another way of what I heard a lot from what you were saying.
I think it really has to be I shouldn't say has to be, but the combination of baby steps and deliberate practice really does work. And if you want to read more about deliberate practice, there's lots out there now. One of the classic books is called The Talent Code. Another one is called Talent is Overrated. They both essentially say the same thing.
Right.
That architect whose job you want wasn't born with it. They might have been born with certain genetic gifts for how clearly they could think, but other than that, they had to learn it all from scratch too. You can use this as a way to learn that. That's one of the reasons that I teach TDD, is not because I want people to write tests, but because it's a wonderful mechanism for learning how all these design principles fit together to build better designs using this chunking mechanism.